Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we will talk about BGP attributes, specifically weight as an attribute. Now as you know, weight is the most influential attribute as far as the BGP path attribute list is concerned. Weight is Cisco proprietary and comes right on top. Higher weight is preferred. The default weight would be 0 if you learn the route through BGP, or if the route is locally originated, the weight would be 32768. Again, higher is better. Weight is not well known, it is optional, and it is non-transitive. You cannot send weight to anyone. You can only configure weight locally. It only affects the local router. Weight can never be sent across to anyone, whether it's an eBGP neighbor or an iBGP neighbor. So to demonstrate how weight is going to work, we will look at this diagram here. So here I have 3 routers in AS1, R1, R2, and R3. And I have R4, which is in AS2, R5 is in AS3, and R6 is in AS4. All my BGP neighborship has been pre-configured at this point of time. So let me in fact quickly show you my BGP neighborship. So 2 and 1 are neighbors. They are forming neighborship on the physical interface. 1 and 3 are neighbors. 2 and 4 are neighbors. 4 and 5 are neighbors. 5 and 6 are neighbors. And 3 and R6, they are neighbors. All the routers are iOS XZ routers except for router 3, which is XR3. So my basic BGP neighborship has been done. There is no neighborship between 2 and 3. They only form neighbors in iBGP towards R1. To demonstrate weight, what we would do is R4 is basically advertising a loopback, which is 4.4.4.4, and R6 is advertising 6.6.6.6. Now, if you look at this diagram, without you making any configuration changes, whether you do weight or local preference, if I don't make any changes, how do you think router 2 is going to route to R4 and R6? Router 2 should basically go directly to R4. Router 3, which is XR3, should go to R6. Why is that? Because they both are not receiving routes from router 1. Router 1 is not the route reflector. If you know, there's a rule in iBGP that route learned from an iBGP cannot be given to another iBGP neighbor. So 2 and 3 would never learn 4 and 6 from R1. So the only choice that they have is go towards the eBGP neighbor. So what if we want that R2 should basically go from exit, not through the eBGP, but instead exit from R3 by transiting R1 and going to R4's loopback, and R3 to get to R6's loopback should go from R1 again towards R2 and exit out towards R4. So to achieve this, what we need to do is we would configure weight. We would use the most influential attribute at this point of time. I will configure weight on both these routers on iOS XZ, which is R2, and XR, which is R3. So what do we need? R3 to get to 6, he should go like this. R2 to get to 4 should go like this. That's our basic requirement. But for them to use R1 as a transit, R1 should send the route to them. They should at least get a route. Otherwise, they have no choice, just one path, which is going to be through the eBGP neighbor. Let's try and achieve this. So let's go to our router 2, and first look at the BGP table. Show IP BGP is summary. I have all my neighbors up and running. If I do a show IP BGP, I can see that to reach 4444 and 6666, I have only one choice, which is through router 4, which is the eBGP connection. I'm not receiving any routes from R1, because even if XR3 gives the route to R1, if you look at the diagram, even if R3 gives the route to R1, R1 would never send the update to R2. Similarly, if R2 gives the update to R1, R1 would never give the update to R3. So R2 and R3 would never learn R4 and R6's route through R1. So my first thing should be done, what I should do is configure R1 as a route reflector so that R1 at least passes the routes of 4 and 6 to 2 and 3. Let's do that. I would go to router 1, router BGP 1, neighbor 10.1.2.2, route reflector client, and neighbor 10.1.20.20, route reflector client. So now R1 is a route reflector, which basically means that R2 should now have two choices. He should have two choices to get to R4 and R6's loopback. One should be the direct eBGP neighbor, and one should be through iBGP. Let's verify that. So go back to R2 and do a show IP BGP. As you can see now, for R6, he has two choices. He can go through R1 to XR3, or he could go direct. Which one is he going to choose? So obviously he's choosing the direct R4 to get there because of, let's see, as of right now, I can see that he is going through R4. And let's see XR3 also. Show BGP IPv4 unicast. XR3 also has two choices to get to 4444. And towards, for 6666, he's going directly, which you can see. What do we need now? We need him to go from R1. What we could do is set a higher weight so that router 2 selects XR3, the iBGP neighbor, which is R1, as a transit and exit out through R3. So to achieve that, all I need to do is go to router 2 and create an access list that basically matches. Let's first check, do we have any access lists configured? I do have one access list. Let me just remove this access list. I don't need that. So let's make an access list 1. Permit. Let's match the route, which is 4.4.4.4. Create a route map, let's say from R4. So when I receive the route from R4, permit sequence number 10, which says if the access list 1 matches, set the weight to maybe 20. Default is 0, right? Because the route doesn't belong to me, it belongs to somebody else. So the default weight would be 0. I'm just setting a higher weight value. For remaining routes, don't make any changes. So permit 10,000. Go back to router BGP 1, neighbor 20.2.4.4, route map from R4 in. So when I receive the route from R4, before I put in the BGP table, what I would do is I would check for the route map. The route map is going to match that access list, which says if this is the route that you've received from this neighbor, then increase the weight by 20, and then he puts in the BGP table. What's the effect going to be if I check my BGP table? Let's do a clear IP BGP star soft and check my BGP table again. I should see the weight 20, right? I do see a weight as set as 20. Let's also go and it should in fact choose R1 now as a transit. We'll just probably have to wait a bit because right now R1 must be taking R2 as a transit. So if R2 starts going towards R1, only then R1 would go towards basically XR3. What's happening right now is that R1 is using R2 as a transit, so obviously R2 cannot go back to R1. So let's wait. Maybe I can go back to R1 and check his table. Show IP BGP. So as you can see here, R1 is choosing router 2 as a transit. Why is he choosing R2? Because for R1, we didn't configure weight. Weight is same. We did not configure local preference. That's the same. It's not locally originated. What's next? AS path. If he goes through R2, it's one hop away. If he goes from XR1, if he exits from XR3, it's 3 hops of AS. So obviously based on AS path, R1 chooses R2. So I would probably need to modify weight on R1 also so that R1 does not choose R2, instead he chooses XR3. So maybe I can go back here and create an access list here as well. Weight is local to the router. It does not affect any other router. It only affects you. So access list 1 permit 4.4.4.4. Let's make one more access list. 2 permit 6.6.6.6. Create a route map from R2, permit sequence number 10, and say match IP address as 6, or in fact access list number 2. If this route matches, which is 6666, only then I would go towards R2. Okay? So let's go back to sequence number 10,000 or 1,000. Let's create one more route map from XR3, permit sequence number 10, match IP address 1. And let's set the weight to 100. Sequence number 10,000. Let's go back to our previous route map towards R2 and set the weight to 1,000. So what I've actually done on R1, I still have to apply my route map. What I've actually done is I made 2 access lists and I made 2 route maps. The access list 1 says, when I receive 4444, which is here, from XR3, when I receive 4444, set the weight to 1000, correct? Which means R1 to get to 4444 will go towards XR3. For other routes, don't make any changes. But from R2 to get to 6666, go towards, set the weight to 1000, which means from R2, 6666 has a higher weight. What's going to happen? R1 will choose to get to 4444, XR3. To get to 6666, he chooses R2. Correct? Let's go and apply this. Router BGP 1, neighbor 10.1.2.2, route map from R2, inbound, and one more route map 10.1.20.20, route map from XR3, inbound. Let's do a clear IP BGP star soft. See, why did I need to do that? Because for R2 to go through R1, R1 must give him the route. Earlier, R1 was going through R2, so R1 was never giving an update to R2. So what I did was that I told R1 that if you need to get to 4444, you go through XR3. And if you want to go to 6666, you should go through R2. The effect of that would be, because R1 is going to 4444 from XR3, he would give the update to R2. And now R2 would have 2 choices to reach 4444, coming from the eBGP neighbor and from the iBGP neighbor. Let's verify that. So show IP BGP. To get to 4444, he is preferring XR1 or XR3 because of higher weight. To get to 6666, he is preferring R2 because of higher weight, 1000. correct? Let's look at R2 now. We had set the weight on R2 also. If you saw earlier, R2 was not receiving an update from R1 because R1 was transiting R2. So if I go through you, you cannot come back to me, right? So I have to change my path. So if I go from somewhere else, then I can give you an update and then you can choose me as a transit. So now if I look at R2, for 4444, he has two choices, XR 3 and R4. Which one would he choose now? So to get to 4444, he should choose, we have in fact set the weight to 20. We should now change this towards XR1. So if I look at show run access list, show run section access list, we had matched the access list for 4444 and we applied the weight for 4444. It should be higher from who? From his neighbor. Default weight is 0. There's no point doing it from R4 because anyway the weight was 0. We don't want to go from R4. We want to go from R1. So it should be applied from R1, not from R4. So let's go back and do a no route map from R4 and create a new route map from R1, permit 10, match IP address 1, set weight 20, remaining route should not be affected, and then router BGP 1. Let's remove this and say neighbor 10121, route map from R1 in. So when I receive routes from R1 now, I would set the weight to 20. Let's verify my table, show IP BGP star soft, show IP BGP. So now I should prefer the higher weight even though it has higher hops of AS. It doesn't matter because weight comes before AS path. Let's wait and watch. Now, there's one problem. Even though I have a higher weight here from router 1, through router 1, I'm still not accepting the route. You remember in the BGP attributes, we had weight as number 1, right? But there's something before weight, that if the next hop is not reachable, that route cannot be chosen for any path selection. What's the next hop through R1? It is XR3. Is that next hop reachable? No, I don't have that route reachable. Since the next hop is not reachable, even though that has a higher weight, it can never be used. That's why R2 is still going to R4. I have no IGP running internally here. There's no IGP running. So R2 must know how to get to XR3's internal network. Only then he would be able to use that route. So I need to run some kind of IGP or maybe a static route. Let's run OSPF internally within the IGP, within the AS1. So router OSPF1, let's set the router ID as 2.2.2.2, network 10.1.2.0, 0000255, area 0. Let's go to router 1. And do the same thing, router OSPF1, router ID, network 10.0.0.0, 0.255.255.255, area 0. And on XR3, router OSPF1, router ID would be 20.20.20.20, address family IPv4 unicast, and area 0, interface gig 0000.120. Let's do a commit. So now both R2 and XR3, they should learn OSPF routes of each other, internal network. So if I look at show route OSPF, I should have the OSPF route, show route OSPF. There should be OSPF routes. Let's check my neighborship. It's still coming up, but let's wait for the neighbor to come up. Again, to make this process faster, you could change your network type to point. If you do that, then there's no DR election and your OSPF neighborship would be much faster. So now my neighborship is back up, and if I do a show route OSPF, I have the route to 10.120. Similarly, R2 should have the route to XR3, which he does, which means now my BGP, I would be able to use the iBGP is now preferred over eBGP because of weight. So now R2 is going to R4 from R1 to XR3, and he's exiting in that direction. Now let's do the same thing for XR3 to go to R4, go to R6's loopback. So what did we want? Right now we made R2 to get to 4444, he's going like this from here. Now we want that XR3, which is here, to get to 6666 should go like this, again using weight. Let's try and do that. So I'm going to go back to XR3. Let's look at his BGP table first. Show BGP IPv4 unicast. As of right now, for 6, he has two choices: to go through R2, which means transiting R1, or to go directly. Which one is he going to choose? Would he go through iBGP? Would he go through eBGP? Well, the choice depends on, have we configured weight? No. Have we done local preference? No. It's not locally originated. Look at the AS path. If he goes directly from R6, if he goes straight to the eBGP neighbor, it's basically 1 hop away, right? But if he goes from R1 through R2, it is 1, 2, and 3 hops away. So obviously, because of AS path, he chooses the direct eBGP neighbor over the iBGP neighbor. So we need to use something before the AS path. So we will use, again, weight for achieving this. So let's go and configure our route policy. So route policy, let's say from R1, and I would say if destination includes 6.6.6.6/32. So I could use a prefix set again. I'm just doing it without a prefix set. Then set weight to maybe 1 to 3, just any number. Else pass. Don't forget the else pass, otherwise there's an implicit drop. End if, end policy. Let's go back to router BGP 1, neighbor 10.121, address family IPv4, and yet I would say route policy from R1, which is my policy name here, in. Let's do a commit. So when I receive updates from R1, I should change the weight to 1 to 3. Let's check my BGP table now. So now our XR3 is choosing R2 because the weight is 1 to 3. The effect of this, that R2, which was earlier going to 666 from R4, even he's still going to go in the same direction. So show IP BGP. It doesn't affect R2 in any way. It only affects XR3. So now I have achieved the requirement where R2 to get to 4444 goes in one direction towards the iBGP neighbor, and XR3 to get to 6666 does not prefer the eBGP. Instead, he goes through iBGP, which is a longer AS path, but still he prefers that because of weight. So you see, just configuring weight would not really achieve it. You should always think that, do I have the route from the neighbor? If I don't have a route, even if I set a weight, there's no point because I didn't receive a route from that neighbor. So you must first ensure that your BGP table has both the paths. One which he is currently taking and the one which you want. It should be in your BGP table in the first place. To achieve that, we configured route reflector first on R1 so that R1 passes the route of R2 to XR3 and XR3 to R2. Then we made sure that the next hop was reachable. We did that with OSPF. Once we did that, then I configured weight. I configured weight on R2, which says to get to 4444, the weight is higher from R1. Remember, you always apply any path attributes, any route maps in BGP in the direction of control plane, never in direction of data plane. So if you look at from a data plane perspective, R2 is going through R1, right? So my direction is outbound towards R1. But I applied the route map inbound from R1 because I always apply in direction of control plane. You give me the update, I will make the change and then put in my BGP table. Once it goes in my BGP table, my routing table changes and then my data plane uses that. Control plane and data plane, they're always in opposite direction. You always apply a route map in direction of control plane. So on R2, I made an access list 4444 and called that in a route map which was from R1 and applied it inbound from R1. But that would only take effect if R1 was sending him the route. If R1 doesn't send him the route, then there's no point of that. There's no point of it. There's no point of that route map. I should first always check that do I have multiple paths in my BGP table. Get that to work first. Get all the routes from both the directions. Only then I can do path manipulation. So on XR3, I did the same thing. I received the route from R1, so I had two choices. Then I said from R1, when you receive the update, increase the weight to 123, which was a higher than 0. So automatically, even though through R1 it has higher hop count of AS, he still prefers through R1 because of weight. Weight is the most influential attribute as per Cisco. I hope this video was informative to you and thank you for viewing.